Hey everyone, in this video I just want to do a couple quick examples of using shells to compute uh, volumes of revolution. So here we have a region which is given by x sine x for our y equals equation and y equals 0. So those are the boundaries, shaded regions right there in between, and we are on the interval 0 to pi. So just from 0 out here to pi. And we want to find the volume when r is rotated around the y-axis. So what I'll go ahead and do is kind of put in this arrow, indicate this is our axis of rotation right there around the y-axis. I'm going to go ahead and draw in, just so we can visualize it, one, say, sample rectangle that I want to use. And notice this one I'm doing vertically. If I were to go horizontal, I would need to rearrange and get an x equals equation, which for this particular one is not really going to be doable. Anything I might try to do to this x is not going to affect this sign, and anything I try to get this x out of the sign is just going to put this other x in something else. So this is going to be a horrible equation to try to rearrange in terms of x. So I definitely want to use vertical rectangles on this. What that means is my axis of rotation right here and my rectangle are parallel. And if they're parallel, then we know we're going to be using shells. So, and if you want to, just kind of draw out sample one just as a reminder, that should look like a simple shell right there. So, we need the R, don't forget. For this, the radius right there, what is the R? And we also need the H, so what is the height of that rectangle right there? So we'll go and find those. So usually the easiest one is actually the R. This is going to be a little dx equation. This distance over from the y-axis is just x, so in this case our R is just going to be x. The height is from the y-axis up to here, it's actually just going to be y. But remember, with dx, we want things in terms of x, so we will go ahead and replace that y with this x sine x. So we'll get our x sine x right there. And go ahead and set up, so we're going to be integrating, don't forget for shells, this is going to be 2 pi r times h, and then r dx. So that's why everything needs to be in terms of x. So go ahead and set up your integral. So we got integral of 2 pi x times our height, x sine of x, and then dx. All right. And we're going to integrate from, our rectangles are going to go over here at 0 all the way over to here at pi. And the way we're going in order on ours, this particular integral you wouldn't be able to do by hand yet. This would require some integration by parts if you wanted to do it by hand, but right now all we're going to be doing is using the calculator Desmos to approximate these guys. So it's more about the setup than the running through the calculation of how to do the integral. These we will get to later, like in chapter 3, talking about how I would actually go through integrating some of those types of things by hand. Alright, so I'm going to go ahead and try to compute that out. If you want to pause the video, you can. I'm going to go pull that up. So just doing it super quick over here on Desmos, we got 2 pi x times that x sine x, and integrating 0 to pi. We get this 36.8798, blah, blah, blah. And this 8, if we go ahead and round that, that's going to bump up our 9 as well. So you actually get 0.880. You go to 3 decimal places right there. And so 36.88 or 0.880, depending on how many significant digits you want, would be the final answer on this guy. So that's kind of the idea. This is a really good illustration of a place where you're definitely not going to get very far if you try to only stick with, say, washers computing. there are places where the equation is just not going to rearrange very nicely. So you do want to be able to do both washers and shells for those types of scenarios. All right, let's go ahead and take a look at this last one. And this last one, we are looking at sort of this idea of find the volume when we rotate it around a different line, the line x equals 4. So we'll go and take a look at that and see what we get. So this region R, it's the same as before. So this is x sine x, 0 to pi. So same region, in case you didn't notice that. But here's my x equals 4 axis of rotation right there. Go ahead and label it. And the same thing's going to happen. I'm going to use these vertical rectangles just because I don't want to try and rearrange this x sine x. I'll go ahead and put the equation right here, just a reminder. And then y equals 0 right there at the bottom. So what we're going to do is take this rectangle, rotate it around that axis. I'll go ahead and draw out a couple of those. The bottom right there. And again, this isn't really to scale, but you get the idea. I tend to shortcut my other sides of these axes. So our R is going to be here. Now this is going to be a little trickier to find than it was before. The height is going to be kind of the same on this one. So we're trying to integrate this pi r h times dx. The h is going to be the same, right? This top function minus the bottom, which is 0. So my h, same as before. I just get x times sine x minus 0, which is just x sine x. And then the r, that one you got to think about a little bit. So if we think about, let's say, I'm going to change my pen color here real quick. Let's say we think about this whole distance here across. This is going to be, for this particular one, from the y-axis all the way out to this vertical line x equals 4. That distance is 4. So that whole distance is 4. From my y-axis out to this rectangle, right? Normally this point we're thinking of is a point xy. So this horizontal distance is x. And what does that leave me with for my r? What it leaves me with is this r is going to be just 4 minus x. So that's kind of the idea you're looking at when you're looking at rotating these shells around a non-x or y axis. Oftentimes you're going to get these sorts of numbers like 4 minus x, or if it were over here, maybe it'd be x minus, -2, so it might actually end up being x plus 2, something like that. But you're just subtracting off of this idea. What's my total distance across, and then what is my x going to be going from one to the other. So this one we'd say is 4 minus x for that r. Alright, last thing is compute the integral out. So we'll just set up, we got the integral from 0 to pi again for those rectangles. And we got the 2 pi r. R this time is 4 minus x. And the last one, the h, x sine x. There's my h, and then of course the thickness, dx. Alright, so go ahead and compute that out, see what you get. And what I got is 42.077. Alright, so that would be the final answer on that guy right there. Just one thing real quick before we leave. There's some homework that you can try on this other page. So practice with shells, there's the homework and the answers at the bottom. So go ahead and try that. One thing I want to show you before we go though is if I were to have, say, an axis of rotation that were on the left side, so maybe like x is -2 or something like that, what would be the R that you would get. So I'm not going to go through a whole problem, but just look at like what would the R be in that case. Alright, so I've gone ahead and drawn kind of your scenario here where if you have an X is -1 axis of rotation, same region as before, I'm looking at what would happen if I rotate around there and what would this R be. So the way to think about this one is anytime you go from your y-axis to your rectangle, you can always think about that as being a distance of x. So that usually helps to kind of just draw that in, start with that. What's left over here for this r is I need this distance right here from this line at -1 to this y-axis, and that distance we know is just 1, right? So if we add those up, 1 plus this extra x, then we're going to get that r is just x plus 1. So in this case, r would be x plus 1, rotating around this line at x is -1. This sort of drawing technique works in, I would say, almost any situation. It's very rare not to be able to do that. So I would highly recommend, if you're confused on how to get the r, just draw it out. X is always from the y-axis to your rectangle. And a lot of the other numbers you can put in either an entire distance or from the axis of rotation and the y-axis, that sort of thing, and look at either sums or differences of those lengths. So that's kind of the idea. We'll go ahead and wrap it up there, and if you got any other questions on the homework or anything, make sure you put those in the forums.